Start recording. Perfect. All right. So, hello everyone, and I'm here. I'm your instructor for this course, Professor Wasim. Well, I tried to change this whole situation, but it did not. So I just let it go like that. Um, because I can't change the background from where I can actually change it. So that's fine. It's okay. Not a big issue. All right, I have Sandy with me, so yeah, I understand Sandy, no problem. So it's your work computer, probably you will have a limited access to hearing, but we would like to start it right now, and I just want to see that if it's getting recorded. There are three things I need to do. One is this one. Yeah, it is getting recorded, so the recording will be shared with you after this lecture. All right. And then we can also be going to discuss the course structure along with some of the other things. I'm sure you guys are right now familiar with your course structure. You know what we already have done so far. And so I'll be sharing my screen with you in a while. But before that, I would like to introduce myself to you. I'm your instructor, Professor Wasim. And it's our second week going on. Your introductions are already graded, so that's a good thing. We only have this activity this week to attend the live chat session or probably to listen to the archive and make attendance marked in the Blackboard. Other than that, we will not have any activity this week. Another one is coming up in week number 3 that is going to be an essay. So when week 3 will arrive, I'll be sharing that announcement with you. What are some important things in this course? Basically, this course, which is Energy Policy ENV 4306, will cumulatively talk about all the causes, reasons, and factors responsible for the impacts of the energy policies or the energy that we had been using in the past. And we are looking forward to adopt in the future. So that's something like, we are kind of covering or kind of just exploring the impacts of the energy from the historical review of the energy, and then we are going to be looking at the middle one, the current one, the present one, and then we will be predicting some of the future of this energy policies or energy consumption in the United States and the whole world. So the first thing that I would like to say is that I should share my screen with you, all right, and you will be able to see the PowerPoint. So let's take a look at it. It should be easier and should not be taking a lot of time. Okay, here we go. And okay, no, I'm not sharing Firefox. Hang on, right? Let me just do that one more time. Share screen, and then I have the week lecture number 2. Allow. That's what I wanted to share with you. Here we go. All right. So this is the title for the Unit 2 live chat today. And we are meeting to explore the topics here that, what we will be looking at, basically energy and global warming. So a little bit about the course structure. As you see that 4306 environmental policy is having, another chat also coming up in week number 6. So I'll be scheduling that soon. This one took a little bit while because I was kind of looking at the course structure and getting myself familiarized with this thing. So after this, it will be easier for you to go back and, join me in week number 6 also. All right, now week 1 is already passed. Your grades are available for you to review for your discussion board, in which we explored not only we actually introduced each other, all right, like you introduced yourself to me and I did to you. And other than those, you also found something related to the policies regarding the natural gas, and then you had to pick out a topic, from the book or the content, to explore. So I found your discussions really, really good. They were awesome. And I'm looking forward to the same kind of information in your discussion posts in the future. One thing that I would like to emphasize is utilizing APA style references and in-text citations, which is very important because with that thing, you will be able to um, provide the evidence that you have written original content. So originality could be defined in many ways. Well, basically, the best thing when we write in academic settings is we have to be providing the content by supported by the within text citations and then APA style references at the end. So in the end of all those discussions, I also asked some reflection questions. I hope you answered them. And in the future discussion boards, I'll be doing the same thing. So in case if you have any questions, you can always reach me out at asma.wasim@columbiasouthern.edu. Okay. Other than that, there is a medium. Another medium that you can contact me is through the messenger or the messages that you can send me in the Blackboard, and I can receive them and can reply back to you. So that shouldn't be any problem. All right. And then my phone number and all the other information is provided in my introduction. So if whenever there is a problem or there is an issue, you can always reach out to me and discuss. All right, moving on. This course utilizes the many you know, I would say phases. All right. First of all, we have to go back in the history and take a look at the energy consumption when it started in the US. Everything started, in 1800s and 1700s after industrial revolution. We started having all of those advancements in medical fields. We received those advancements in industrial fields and so many other, like, we grew, our population also grew. Right now we are 8.2 billion people in the world, but if you just try to go back in the history, you will find that human population did not grow until 1650 and 1700. So that was the dawn of industrial revolution. Whether well, our although our lives actually improved with this industrial revolution from different aspects, at the same time we also faced a lot of problems. The problems were that knowingly and unknowingly, we started using a lot of these natural resources about which we did not know in the beginning. Land was free, everything was free, so the best suggestion was to move on and just perform some of the developmental projects and make economy stronger. But afterwards, what happened was that we started seeing the repercussions and everything just started reacting back. Even our natural environment started, reacting back with some of the problems that we are seeing right now that are getting worse day by day. So there is a strong relationship between the energy, industrial revolution, and global warming. Now, what exactly is a global warming? What kind of energy sources we do have? To understand the energy policy, we need to understand first the basics of or the foundations of these two topics or factors or fields actually, what exactly do they mean. So this is the unit 2 lecture we are starting right now, and let's go to the first slide. Energy is not something that was born on its own. So it's the effect of different processes in the Earth's crust that we are having this kind of energy sources. Well, some are quite natural. I mean, you can just find them in the solar light. Some of them you can find them in the wind. But everything exists because of the sun in our universe. Other than that, you can just think about the previous structure of the earth, the way the earth formed, the way the earth actually got into the hole, and then we started having all these things gradually. It was a gradual process, the formation of earth. We saw many periods in the earth, like, you can see them, that the biggest one is the Phanerozoic. All right, a little bit geology is involved here to understand the energy, um, the beginning of energy or the start of energy in our world. on the earth. So Cenozoic is the era, and then we have periods, different kind of periods. So the best thing is to understand these because we have heard some of these names already, when we watch some documentaries or when we watch some movies, like Jurassic Park and many other, movies or documentaries related to the historical formation of Earth. Now, in this one, until this time, there are different processes going on in the earth, but at the same time, when you go back to the earth's history, you will find this period when we had a bigger living organism existed on earth, like dinosaurs or different kind of 99 species of dinosaurs that they existed on earth. And then afterwards, you would have heard about some theory, like a Big Bang theory, because of which the earth was um, collided with an asteroid. An asteroid kind of just created a chaos on Earth, and these living organisms were completely vanished out of the sun, of the Earth's surface. So there are gradual processes. There are different theories describing all this process. One theory is about the geology or the geological theory, which says that what happened was, when an asteroid hit the Earth, all this life was actually completely gone and buried into the Earth's crust because of the temperatures and pressures in the Earth's crust. They turned into coal, natural gas, and petroleum. That's what's the fossil fuel formation theory. So we started getting coal from here. Okay. That's why it's called like Carboniferous period, or you can just known as like the Permian period, or Devonian, and different kind of other names are given to it, Cambrian and Precambrian, because of the important thing of based on this theory that when the Earth was hit by an asteroid at that time and everything was completely buried into the Earth's crust, not only the living organisms like dinosaurs, but forest swamps, forests, taller trees. If you just can imagine the height of a dinosaur at that time, you can also imagine what kind of trees would have been found in those eras. So this was like the start of the energy in the world, coal. With the coal, we were given this blessing because of that gradual development of burial of these living organisms. Now, wherever the structure was quite stronger, of this molecular structure of these things was stronger, we found coal in that area. Where it was a little bit weaker, the molecular structure, the atomic structure, there we found something like liquid like petroleum. And then when it was extremely weaker, or you can call weakest, it was basically gas, natural gas. So methane, CH4, natural gas, petroleum, and coal. These are known as the fossil fuels in our world and on the earth. And we had been taking a lot of advantages out of these fossil fuels for a long time because these fossil fuels provided us like a support in the industrial development. We got electricity with it. Electricity is the biggest use or the consumption of these natural resources, and we started moving on, and there was no way to stop us because that was the beginning of the industrial revolution. So after that, you can see that what happened in the US pre 1820s, these are divided into different periods. The way industrialization started, the way we started using energy in our world, all right, at the US. So period one was they're divided into different periods. Period one is basically the pre-1820s. It's dominated by human animal power, wind, wood, and water power. So you can see how people are basically doing their work with their own hands. Probably they are utilizing livestock also, all right, but they are performing the activities on their own. This was a good era. There was nothing going on in this period except people would get tired, they would do a lot of work, but they would go to bed and would sleep very nicely. So that was something which was a good era. So afterwards, in period two, you can see that it started from 1820 to 1914, industrial era dependent on wood, water power, and ultimately coal. Now we discovered coal in that period. Coal is something that is full of energy, provides us electricity, it provides us burning. With the burning of coal, You get a lot of these industries running on, you can also find manufacturings going on. We are just having access to a lot of these necessities, all right? Amenities, necessities, whatever you call, but we all have access because of this coal, you know, to all these amenities. We wear clothes, clothing industry, we wear shoes, shoes industries. The biggest is the technological advancement, and technological advancement without coal you cannot imagine, because electricity is the biggest output of this coal. Coal in the beginning was very, very cheaper. It was abundant because of the thinking process of the people that we have a lot of land, we have to grow, and we need to have energy sources. So basically coal was consumed more, or consumed. For years and years, coal was very cheaper. But then when scientists found that coal is going to be depleted, because when you find something known as non-renewable, it will not be renewed, it will not be refilled, it will not be replenished. So automatically it has to be gone, one day vanished from the Earth's crust. So even after using it for 200 years, we still have a lot of these deposits of coal in the world. It is supposed that we still have 200 to 700 years of coal available in the Earth's crust that we can utilize without any problem. But the problem with the coal is not only that it is abundantly available in the Earth's crust, it is still cheaper than other fossil fuels. But the problem is with the emissions that coal generates, or coal basically emits in the process of generation of electricity. So this is another image which shows the story of how we started industrialization, we started energy usage, the oil is actually burned, the factories are running, many residential, industrial, transportation is dependent upon the oil and coal and natural gas. You again see this process, how the coal stacks are basically emitting emissions into the atmosphere. That was basically the start of the environmental problems at that each that era, associated with the energy consumption, especially fossil fuels consumption. This is another image which is showing that how people actually worked in the coal fields, basically coal mining, all right, underground caves or underground mining, along with strip mining. If you just remember, we had been seeing these cases of blasting the surfaces, mountain surfaces, rooftop removal process because of this blasting, how much problems we have generated in those areas, not only in terms of emissions by burning of coal, but at the same time, you also can find that how can the coal byproducts can be part of the waters and soil, just making that land deserted for for a long time. So that land will be taking a lot of time to come back to life, because we are kind of removing the top layer of the mountains for getting coal. So coal can be coal can be extracted or gained by two methods. One is underground coal mining. The other one is strip mining. You cut the strips of the mountains to get the coal. So these are also something like that. Then again, you have to do the underground underground mining of the coal. That was dangerous. Children or probably slim people would have been to use to get that coal. You can see how the person is moving inside the cave, to get the coal. So basically, that was something in this procedure. These people would have been exposed to so many different contaminants or pollutants, air pollutants, and they would just receive some kind of diseases like I think it was the black lung disease, and then they would die because of that. So that was one problem. Then period three started from 1914 to 1945. It's 1945. It's been written as here as 91, so it's 1945. Then oil emerged as the leading fuel in electrical power. So not only that coal was providing us electricity, but we considered petroleum also to get electricity from there. already there was a lot of pressure on petroleum to run the cars, buses. But still, we wanted to shift the focus of the electricity generation from coal to petroleum. So petroleum and coal were the major sectors or fuels that were providing us electricity. And period 4 was 1945 to 1970s. We already have seen that period, some of us, and it was a post-industrial economy dependent on oil, punctuated by the 1970s energy crisis. So when everything was gaining its popularity, like, energy sources, we started seeing energy crisis at the same time because some countries had abundant oil, some countries did not have. So it was kind of a monopoly that, the countries played and put some embargoes, and then that was some kind of a, trial method, to make petroleum the most expensive fuel in the world. So this was something coming out of the same reaction. Period 5 was 1970s post. So post energy crisis America still tied to carbon with some rumblings for change in later years. Now, the confused economies of the world, of the United States, I would say, when the economy kind of just faced a little bit backlash, from the energy markets, then there were different kind of thoughts, different kind of concepts. Conceptual work was in the process. There are different things in the process going on, like, somebody would think about having alternative fuels. Okay, fine. If we just lower the dependence on the coal, natural gas, and petroleum, then we can have alternative fuel. Nuclear was another non-renewable energy source. The formation of coal, petroleum, and natural gas is a little bit different than the uranium. Uranium is already, included in the Earth's crust. It's an element. But this element has a isotope, radioactivity. It emits radioactivity, and that radioactivity is used to generate electricity. So what happened in this situation was, well, nuclear didn't have any issues with the emissions or anything like that. It was considered cleaner. But the problem was with the radioactive waste, because in the history we have seen some of the problems with the nuclear energy disasters like Chernobyl. Recently we have seen Fukushima, and then 3 Mile Island. So basically those are kind of, basically pointing out to the fact that we should be staying away from that. But again, we should remember it's something that is also as stronger as natural gas to provide us electricity. Natural gas is also considered a little bit cleaner. It doesn't have any emissions compared to coal and petroleum. So we are also talking about different kind of mixtures here. One is coal, extremely abundantly available in the Earth's crust right now in the depletion process, but having high emissions associated with them. Similarly, we do have natural gas, which is a little relatively cleaner than coal. The process of formation is the same, but then it is considered cleaner than coal and petroleum. Petroleum and coal are kind of hand in hand together for causing a lot of or emitting a lot of air pollutants into the atmosphere. Nuclear is formed from nuclear fission process, which basically would involve taking a uranium isotope 239 or polonium or radium, anything like that, and that will be you know put in the hot water, and then rods are used to generate the electricity from that process. So uranium is good, but again, it's non-renewable. It will be depleted at one point in the Earth's crust. So that's something, that's like the fossil fuels and all these things. Then when we started thinking about alternative fuels, well, different countries in the world were already trying, generating fuel from corn, soya beans. In Brazil, that was the biggest industry for like soya beans industry and biofuels industry, bioethanol. So bioethanol or ethanol was basically made from that. So the shift in 1980s and 85, 90s were shift from this conservative type of or traditional type of approach towards energy consumption towards alternative fuels. So the first fuel was biofuel. Ethanol was formed. Ethanol was used in different kind of industrial processes. At the same time, industrial, like, the cars, ethanol-based cars were, created at that time so people could buy and people could run them. But based on several different issues, they didn't pursue those ideas and they still remained with the traditional gasoline running cars. Again, replacing petroleum and traditional fuels with wind energy renewables. On the other hand, renewables are kind of effective. They are modern technological innovations in the field of energy development. But at the same time, if you just take a look at these windmills or solar photovoltaics or these hybrid cars or electric cars, these are all the outcomes from the efforts of the thought processes, based on finding something alternative to the fossil fuels, finding something better than. So basically, we could run for a long time without any problems in the world. Now, what are those problems that these fuels are creating? Traditional fossil fuels and conventional fuels like nuclear. That's the main point. In the US, if we take a look at energy use in energy usage in the USA historically, all right, in 1800s, you can see the coal was basically used as a primary fuel for generating electricity and for supporting residential sectors, so that is something like we kind of seeing that, in the beginning, like 1860 to 1960s, in 100 years, coal was used highest in the country, for electricity consumption. Other than that was basically the wood had been used for a long time, so it was already high. All right, so with utilizing coal, all right, you can see the coal curve is kind of just moving on and the wood curve is coming down because we found alternative fuel as coal, to burn for electric purposes, electric generation purposes. Then oil started uh, getting used in 1860s. You can see that how it went upwards, all right. And then you can also see at the same time natural gas was also started, to provide us all these processes at the homes, the way we require them to cook, to burn, to warm. All these, energy um, sources are used for all these purposes. So from 1800s to 2000s, you can see what's going on with the fossil fuels. And this is the relationship with what's happening right now with global warming. Global warming is not the only effect that we are getting out of these energy sources, but can be it's such an like a great in effect, that we are seeing, that how the climates are changing right now. So from 1880, since we started burning all these fossil fuels, you can also see that the Earth's temperatures changed from 1880s to 2000s, quite higher. We are still predicting that there can be some more increase in the Earth's temperature in the next 10 to 15 years. People who spend times outside, they probably would not be able to do so. Right now, we have so much pressures on using air conditioners at home. Without air conditioners, we cannot live in the in the hot areas, right? So that's something which is happening. Now, where was this recorded? In Hawaii, there is a lab which is known as Mauna Loa. In Mauna Loa laboratory since 1880s, 1800s, these records temperatures increase have been recorded. So it's kind of authenticated by a data. Authentic data, it's evidence data. Still, people would not believe that this phenomena is occurring. The Earth is getting warmer. The average temperature has risen about 1 degree Fahrenheit in the last century, and the rate at which the temperature is rising is accelerating. Every day, we are seeing some kind of problems related to climates. The difference between climate and the weather. What is the weather and what is the climate? Weather is basically measured in the terms of the daily changes in temperatures that we receive in an area, in a geographical area. For example, a weather today could be cloudy, a weather today could be rainy, it could be a rainfall, precipitation would be 80% higher today, it could be humid, it could be hot, it could be cold. But when we talk about climate, climate is something that can be the averages of all those weathers over the years, which sets the trend of that geographical area. Or you can say, well, basically, the climate of this region is dry. So you just cannot say today it's dry, but you say the climate of this region is dry. Look at the deserts. Deserts climates are dry. Look at the tropical rainforest. Tropical rainforest climates are always full of rainfall. It's rainy, it's wet. So we describe like that. So if somebody is thinking about if global warming is not real, it is happening, it is real, it's here, and its effects are giving rise to a frighteningly new global phenomenon, the man-made natural disasters. So already the Earth was having something known as anthropogenic gases. Sorry, the atmospheric gases. Those gases are CO2s, carbon dioxide, CH4, methane, nitric oxides in the form of probably nitrites or nitrates, okay? And then we could have ozone, tropospheric ozone, O3, water vapor, okay, upward in the atmosphere, which are playing a role, a phenomenal role. What is that role? Let's take a look at it. All right. So I'm going to show you how this whole situation happened. We're going to spend like 10 minutes to understand what exactly is this greenhouse effect, how it's making the world warmer. But before that, let's, read a little bit to brainstorm. Global warming refers to an average increase in the Earth's temperature. All right. A warmer Earth may lead to changes in rainfall patterns, a rise in sea level, and a wide range of impacts on plants, wildlife, and humans. A warmer Earth. What does that mean? Why was the Earth not warmer before? Was it normal or warmer, or was it not warmer? That's the main question. So since the beginning of the Earth was like a gaseous ball, right? It was settling down into lithosphere, the layers of the Earth, atmospheric layers. So some parts of it got colder. The colder regions of that gaseous ball turned into the solid surfaces known as lithosphere. Mountains were formed, oceans were formed because of that geologic theory that happened long ago, all right, which basically killed all the animals on the planet and which killed all the trees on the planet. So after that, you know, it was believed that, before that, actually, it was believed that the Earth lithosphere was formed. So it was a hard layer. Below that, we have mantle, upper mantle, lower mantle, then we have inner core, outer core, and different kind of that Earth zones, layers of Earth, right? This is lithosphere. This is upper mantle. This is a asthenosphere, all right? And then this is upper mantle, lower mantle, inner core, and then this is outer core, and this is inner core. This is made of nickel and iron, and it's quite hot. Right? So above that, you can imagine the processes that could be quite hotter. So going on with this theory of this Earth formation, we also got atmosphere. In atmosphere, we had all these atmospheric gases like CO2, CH4, okay? We had nitric oxides, we had water vapor, all right, H2, and then we had ozone 3, all right, which is tropospheric ozone. All these gases were already there when the Earth was formed. So what happened that we call the Earth right now the warmer Earth? That's the main question. So may lead to changes in rainfall patterns, a rise in sea level, and a wide range of impacts on plants, wildlife, and humans. Right now, the composition of the dynamism of the ecosystem is quite much challenged. There is very low resilience left in Earth to resist against the changes that we are imposing on them. So why is it considered warmer, and what's basically anthropogenic? Anthropogenic is basically man-made um, changes. Anthropogenic because of the humans. Anthro is humans. So the main cause of global warming is human activities. Finally, we reach to this conclusion that everything was existing already on the earth. Everything was fine, but then something happened that everything got in a chaotic situation. There are natural sources. I'm going to show you how. The greenhouse effect. So the greenhouse effect is making the earth warmer. How? Well, prevent some heat from escaping the atmosphere, allow incoming radiation to pass through the Earth's atmosphere. Keep in mind these 2 points. This is a natural process. It happens all the time since the beginning of the Earth. This has been there and has kept the Earth's temperature about 60 degrees Fahrenheit warmer than it would otherwise be. Okay, so current life on Earth could not be sustained without the natural greenhouse effect. Also remember this point. Now let's come back to this empty slide and I'm going to show you how. So this is basically the sun. Okay. All right. All right. This is the sun. It emits its light in the form of ultraviolet or infrared radiation, IR or UV. Okay. And this is the Earth's surface. Okay. And this is basically, you can just see these, this is the ocean, like this, and this is basically the Earth, other layers below that. There could be vegetation, plants, all right. There could be plants and there could be water. So you can see this is water, all right. And these are plants. Okay, so you can call it vegetation. Now, this is the situation of the Earth right now on the Earth. Let's take a look at, we will take into view three scenarios. First scenario is that when the Earth's these atmospheric gases, which were already there, all right, atmospheric gases were quite thinner. This is the thin line. I'm showing you thin line. Okay. We are not thickening it. Thickening could be a different one. These are CO2s. These are CH4. These are nitric oxides. These are water vapor. All right. And then you can also call that mm, ozone, which is tropospheric ozone. These gases are necessary to maintain certain warm on the earth to sustain life. In the first scenario, what we are looking at is that in this scenario, basically, it was quite thinner. So you would have heard about the ice ages happened on Earth for a long time. We have seen 6 ice ages. We have seen five ice ages and 5 extinction phases. We are right now into the sixth extinction phase since 2000s, but we are not seeing that because it's a gradual process. It's not based on punctuated equilibrium. We will be facing something. Gradually, everything is happening in the Earth's crust. Now, this is basically the thin layer, and this is the sunlight that is coming in the form of infrared radiation and ultraviolet radiation. Now, when it hits the Earth, you know, it is absorbed by these plants for photosynthesis and also in the water. You know, in the water, we have phytoplanktons which utilize, sunlight for making their own food, which are autotrophs. So these plants make their own food, but there are, areas on Earth which are not vegetative. There could be like some surfaces which would be shinier than the plants ones, vegetative or rocky surfaces that could be able to reflect some of this, infrared radiation towards the atmosphere. Now, what happens in the atmosphere in situation number one? Well, some of it is absorbed. Like for example, 60% is absorbed, but 40% is not absorbed, and it goes back towards the atmosphere. So in the presence of this thin line, all of this ultraviolet radiation will get scattered back, into the atmosphere, and nothing will come back towards the Earth, because of which there will be cold temperatures on Earth, and the living organisms will not survive. So that's how we see an ice age. Okay, because most of it gets and reflect back, scatter into the atmosphere. So we don't see anything coming, like, there's no effect on Earth which could cause warming effect. Another point is this, that now this is the first thing, all right? You saw that, okay? And now we will see another one. Let's see. Let's see, now we have a layer which is quite thickened like that, okay? This is the natural layer, All right, this is the natural layer. It's not thickened yet, but this was quite thinner. All right, this was 90%, 100% thinner. We would consider it like 80%. Okay, and then you can see how actually what will happen in this situation. Now, in this case, the incoming solar radiation will go back, all right, and this 40% will reflect back towards the atmosphere. Some of it will be absorbed, all right, and some of it will be reflected back because it's right now thicker than this line. In the beginning, in which we had ice age on Earth, right now you can see it's a bit thicker, which is absorbing these gases, but some of these ultraviolet radiation is reflected back towards the Earth, causing normal warmth on the Earth. This is causing normal warmth on Earth, which is sustaining life. All right, so this is the second situation. That's why we are living here on the Earth's surface, because the situation is right now like that, a little bit like that. Not exactly like that, because what happened afterwards, that's the story. Then afterwards, what we started doing, we actually started emitting um, fossil fuel combustions, emissions of CO2s and all these gases. And then it already, it thickened the already existing sheet, the blanket of gases that already existed. For example, if it is like this, we can consider them more thickened like this. Now it's a quite thickened sheet of these gases, and these are known as anthropogenic emissions or man-made emissions. Okay. So now what happens in this situation? Now, as it's quite thickened, all right, in this situation, when the 40% will go back towards the atmosphere, the ultraviolet or the infrared radiation, everything will come back towards the surface of the Earth because it doesn't find spaces to get scattered into the atmosphere. So most of it, you can say 40% is coming back towards the surface of the Earth, causing more warming impact. This is called global warming. This process is known as greenhouse effect. Okay, so imagine these are known as GHGs, greenhouse gases. Why are these known as greenhouse gases? These were once known as atmospheric gases, which were protecting the earth from getting colder and getting, warmer. But right now, the current situation is because of the fossil fuels emissions, because of the industrial manufacturing processes and all those things going on, this sheet has got thickened, because of which we are getting more warmth on the earth, and it's called as known as global warming. So it's all related to energy consumption. Which one? Fossil fuels energy. Let's think about it. A greenhouse is used to grow plants and help in the winter. That's what we consider, what we do. When you want to grow plants in the greenhouses, this is what they follow. The same pattern what Earth is following to giving the plants and the environment warmth. So greenhouse trap heat from the sun, and the glass panels keep heat from escaping. Thus, the greenhouse can keep plants warm during the winter. Greenhouse gases trapped in the Earth's atmosphere have the same effect. So this is very similar to what we know as greenhouse effect. What are those greenhouse gases? Water vapor, carbon dioxide, CH4 methane, nitric oxides, all right, ozone, and CFCs, chlorofluorocarbons. Now, every gas has a different kind of potential to cause global warming. If you just see, the most abundantly caused are the water vapor, CO2, CH4, NOx, O3, and chlorofluorocarbons. But when you come from the like the most potential ones, CFCs has the most potential to cause global warming. But the only fortunate condition with that is um, it is also emitted lesser in amounts. All right, so that's why we don't have that much chlorofluorocarbons. Since 1970s, they were more, but right now we have shifted our focus to, receive, like, get more of these alternative products, which emit not CFCs, but R3 gases, which is basically a substitute for CFCs, chlorofluorocarbons. So it has more potential, but it's luckily not emitted more. Well, CO2 is emitted more. It's the biggest culprit of global climate change. Methane is the second one. Nitric oxides is probably, one after another. Ozone, the the least one probably, the second least one, and then the first one is water vapor, but the most abundant, but it doesn't cause that much problems unless they get mixed with these gases and fall on Earth in the form of acid rain. So that is another story. Now, there are natural processes also, which are responsible for causing all these gases part of the atmosphere. Those are volcanic eruptions. Those are probably, yeah, volcanic eruptions are topmost, about which people think that, you know, these are these could be the causes in the beginning when you know opponents did not have any other ideas. They said that the natural processes of Earth, the orbital movement of Earth, or probably the volcanic eruptions of Earth could be one of the reasons that these gases could be higher in the atmosphere. But if you just take a look at it, the volcanic eruption, it emits a lot of ash, so that is going to be having a cooling impact. So that's completely opposite to what we saw. And on top of it, there are very small instances where these earthquakes occur. Right now, we are hearing that every region is having a fault line or probably some kind of seismic activity going on. But that also could be one of the reasons of these changes. But again, we don't have any solid clue about it, that if it's happening because of all these, problems. There could be one thing that could be very evident with it or authentic, that, when we perform a hydraulic fracturing, you will feel some shaking of the earth. That could be related to the earthquake. But again, on bigger, massive scales, if these earthquakes happen and the volcanic eruptions occur, that would have a negative impact to the warming, that would be cooling, right? So going and moving onwards, all right, diagram presenting the greenhouse effect, you can see how it basically works, okay? And if we just take a look at the composition of other planets with the Earth, Venus is basically having 96.5 carbon dioxide. Life is impossible there. Nitrogen is 3.5%. Oxygen is found in traces. Traces is still there. Argon is 0.007% and methane is 0%. This is inert gas, all right, which doesn't um, kind of react with anything. So it's called inert gas. Now, this is Earth, how it's habitable, how we can exist on Earth. 0.03% is carbon dioxide, 78% is nitrogen, 21% is oxygen, 0.9% is argon, and then 0.002% is methane. Okay. On Mars, 95% is carbon, 2.7% is nitrogen. Yeah, oxygen is 0.13%, argon is 1.6%, and this is 0% methane. So life on these two planets is not possible, but life on this planet is only possible because of the combination of these gases. It's quite natural. All right. It's not something that which man has performed it. Climate change is the long-term average of the weather patterns in a specific region. Climate can either get warmer or cooler. People's effect on the climate a lot. Well, basically, people began, altering the climate during the Industrial Revolution in the late 18th and early 19th century. There was a big push towards change, economic development, and because of which, we started doing so many other activities which were not good for the earth. So 1960s, well, in the beginning of these policies, or what we started doing in the beginning, you would have heard about tragedy of the commons, a very common concept about considering everything yours, right? So we also considered lands ours at that time in 1960s, and then in 1800, sorry, the trend started in 1880s, 1865s, and then people were allotted lands. They were offered to get the land for $16, which was quite a big sum at that time. And the bigger corporations that you see right now are actually the children of those people, basically who started all these journeys, for economic independence. So basically, they earned, or probably they received the land for $16 for 5 years to perform any developmental activity, and that could be farming, could be mining, could be any other thing, and that resulted in completely chaotic situations of the earth. In 1940s, we realized we did a lot of bad things to the earth. Now it's time to rebuild the earth. It's time to reverse the procedures. But things were not the same. Science foundations were formed, policy formation started happening. In 1945, the first research foundation was formed to research about environmental problems in in the country, and then afterwards, many different environmental laws came into being. They were implemented, but it took a lot of time since 1960s onwards to 1980s. And then you could see several laws: Clean Water Act, Clean Air Act, all right, all right, not Soil Act, but you could probably find something like Toxic uh, Substances Control Act, TSCA, energy laws. Energy laws were something which always faced some kind of troubles. And there is a reason behind that. The biggest reason behind that is the fossil fuels industries, fossil fuels domination in the world. And it took a lot of time for the US even, to fight with the monopolies of these industries. But we cannot completely rule them out, from giving us electricity because we have all the infrastructure built up to get those kinds of, energy or electricity through burning of the fossil fuels. So now, through population growth, fossil fuel burning, and deforestation, we are affecting the mixture of gases in the atmosphere. We are trying to just, making them more and more. Carbon dioxide is the first gas that is responsible. 60% of our ecological footprint or per capita consumption is carbon dioxide. From all our activities, not other gases emerge, but only carbon dioxide. So that's the main problem. Carbon dioxide is one of the most abundant greenhouse gases in the atmosphere. The main source of CO2 is the burning of fossil fuels. Deforestation in Brazil has earned it a spot as one of the leading carbon dioxide emitting countries. Okay. Although there is like a livestock and cattle ranching industry quite on top in the Brazilian region. Methane gas. While trash and landfills, animals, and deforestation all produce methane gas. 60% of global methane emissions are related to human-related activities. Well, trash burning, okay, or landfills. Well, this is actually uh, beneficial in one way. You know how? Because natural gas is considered cleaner than coal. Hang on, let's go back. It's considered cleaner than coal, and through this process, we can actually get it renewably. So it is considered a bridge between renewable and non-renewable energy sources because we can get it synthetically from this process of like landfilling, biomass burning, livestock, and then forest burning. Well, these two activities could be quite disastrous, for the earth, because through this industry and through forest burning, we are actually losing ecosystems. From the other one, we are getting a lot of pressures on the um, carbon dioxide and methane emissions. This one is also something which, but this one is effective. The reason is that because when landfills are formed, when you put a pipe inside, after some time of the decomposition period, CH4 emerge on top of those landfills. On the roofs of those landfills, you can just get the natural gas and can connect a generator with it and get electricity. So that's something which is quite beneficial. But you cannot again think about landfilling in the US. Landfills are too much problematic, too much complicated. It has to be designed in proper engineered terms or properly, like with measurements. So basically, a bathtub in a bathtub kind of technology could protect the water resources of the earth from this landfill. But it is a record that if landfills are going to be formed, after some time they will leach the harmful chemicals into the groundwater quality, groundwater reservoirs or probably wells, because of which people could be having a lot of problems. We have seen these problems back in the history. Nitrous oxide is in fertilizers. We already have a nitric oxide, a nitrogen cycle in the atmosphere. We have carbon cycle in the atmosphere. We have other cycles in the atmosphere which are known as biogeochemical cycles, and which can be sustained only if we would not be putting our effort into it by burning off different kind of fuels. So Nitric acid in fertilizers. We already have birds. We get it through birds' feces, and then they decompose and go into the ocean water, and then it evaporates in the atmosphere, combined with the water, fall on Earth in the form of rainfall. And then we also have them embedded in the leguminous plants. Basically, when the lightning occurs in the sky, the legumes open and then we get nitric oxides. But other than these two natural sources of nitrogen, we started adding more nitrogen into the soils through fertilizers, nitrogenated fertilizers, which are the biggest cause of having excessive nitric oxide in earth. Animal manure management and sewage treatment all release these nitrogen emissions into the atmosphere. So these are the man-made. Ozone fuel combustion is the main source of ozone. And then chlorofluorocarbons, well, refrigerators, these were in aerosols and refrigerators, the use of CFCs as a coolant has been discontinued, but the effects of the damage done will persist for thousands of years. So it's non-renewable. This is the US energy composition, all right, what we use. We use coal for the electricity generation, and most of, if you just take a look at it, this is the division of different kind of sectors which utilize fuels in their combustion processes. Power stations or electric generation, have 21.3% leading from all of other ones, which are the transportation fuels 14%, industrial processes are 16.8%, agricultural byproducts are 12.5%, fossil fuel retrieval, processing, and redistribution or distribution are 11.3%, residential, commercial, and other sources. Cumulatively, on average, you can say that approximately currently 34% coal is used for electricity generation, along with 20% natural gas and along with 20% nuclear fuel, along with just 1 to 3% of renewable energy sources for electricity generation in the US. If you just would like to compare it to the previous ones in 2008, when I was actually doing my degree and I proposed, all these emissions from the fossil fuels, those were actually 53% coal was used for electricity, or 53% of electricity came from coal. So basically, that was the highest at that point. And then we started moving towards having lesser ones by changing ourselves to alternative solutions. Effects of global warming. Environmental changes can lead to appearances of new diseases. Environment is changing, ecosystems are changing, giving new threats to us. Old diseases in new places, while disease carried by insects or other vectors are especially likely to be affected. Some affected diseases that still are not gone in developing countries are malaria, plague, dengue, and flu. Many have advanced their strains, COVID-19, all right, etc. All right. So this is something which is happening. And then help prevent climate change by energy efficient technologies. That's still a debate. All right. Should we use that approach? Should we use a policy approach? So far, behavioral approach or the consumption approach by consumers have proved to be very efficient because they had been receiving a lot of incentives for changing their behaviors. Use fluorescent light bulbs, LED bulbs. Drive less, walk, carpool. Recycle and buy recycled products, much better. Turn off electronic devices when not in use, and then plant a tree. So these are all some of the behavioral options that or habitual options that are provided to conserve energy. International responsibility is here. Climate change is a global problem. So United Nations is taking an increasing role in the involvement in climate change. The United Nations Environment Program provides governments with tools to promote climate change awareness. UNI program is on top. The Kyoto Protocol, right now, Paris Agreement. All right. So these are all some of the international agreements towards climate change. What is the national responsibility? Well, Congress has passed Clean Air Act, Air Quality Act, Clean Air Act extension, Clean Air Act amendments in 1977 and 1990s. Numerous state and local governments have enacted similar legislation. either implementing federal programs or filling in locally important gaps in federal programs. If you just take a look at it, all their aims is to decrease the emissions of greenhouse gases. So this is a debate which will continue in Unit 6 when we will look at the energy policies, whether they are effective or not, where we look at the whole situation of renewables and non-renewable energy systems into the United States. So I hope we don't have any more. These are the references. In case if you have any questions, you can let me know. All right. But we are actually done for Unit 2. Anybody with me? No, I'm alone. All right, so I'll see you next in unit number 6. I'll be announcing that lecture soon. Have a great day. Enjoy yourselves. Enjoy the rest of your session. And if you have any questions, please let me know. Have a great day. Bye-bye. Now, how I close it? More probably here. And then probably here. Okay.